So today we're going to cover section 5. We're going to be able to find and use slopes of lines. So the first thing we're going to do is review the formula for slope. So you probably did this multiple times in middle school. You probably did it in pre-algebra, and then you probably did it in algebra 1. So the slope of a non-vertical line is the ratio of the change in y, which is the vertical change, to the change in x, the horizontal change. So the slope is always indicated by the letter m, and it's going to be y2 minus y1 over x2 minus x1. So it's always rise over run. So you might have heard that. So the rise over the run. And you can either find the slope of a line from using this formula. You could also find it from a graph. Either take the two ordered pairs they give you and then use the formula. Or you could count, if it's on a coordinate plane where it's like graph paper, you could count the rise and the run. Or if they give you an equation, and we're going to cover this in a minute, for example, y equals 3x plus 1, the slope is always the number in front of x when it's written in y equals mx plus b form. Pretty good there? Now, somebody once told me this little story because they were struggling with, and the common mistakes I see when students are using the slope formula is they forget to put the y on top of the fraction. They always put x. So somebody told me a story that their teacher in middle school told them that you're going to have a picnic, and you're going to have a picnic on the side of a mountain. So the side of a mountain has a slope to it, but you want to set up your picnic table. So these are going to be the legs of the picnic table, the x's, and at this picnic table you're going to be serving yum yum juice. So that you're going to set your glasses of yum yum juice on top of the table. So this is a little trick maybe to help you remember that you subtract the y's on the top and the x's on the bottom. Whatever is going to help you remember. Now, these little numbers that are here, these are not exponents, they're like labels. So you could sort of think of like you have order pair number 1, which has the x1, y1, and then you have order pair number 2, which is the x2, y2. So this is the slope formula. Here are different types of slope. You have a positive slope, and it's going to rise as it moves to the right, so it rises from left to right. A negative slope falls from right to left to right, and then a zero slope is a horizontal line. It's going to be, for example, let's say this is the number 1 here. If I added numbers to this graph, this would be the equation y equals 1. When it's a vertical line, it's up and down, and it has an undefined slope. So this is no slope at all. And this would be, for example, let's say this is right here at hitting it at 2. This would be the equation x equals 2. You need to memorize these. You need to memorize that a vertical line is an undefined slope and a horizontal line is a zero slope. When you do the formula, what would happen is you're going to end up, when it's a horizontal slope, you're going to end up with a 0 on the top of the fraction after you do the formula, and then a number in the bottom. When it's undefined, you'll get a number in the top of the fraction, but a 0 would be in the bottom. And this would be an undefined slope because we can't divide by 0. Now to tie all of this in geometry is we have a theorem. And the theorem is the slope of parallel lines. So in a coordinate plane, two distinct non-vertical lines are parallel if and only if they have the same slope. So as soon as you're given two equations, if you notice that their slopes are the same, then you know the lines are parallel. Also know that any two vertical lines would be parallel. So in this equation, let's say we came up with the equations of the lines, the slopes would be the same. Next, we have a theorem for perpendicular lines. And I know you guys can't see that. Let me just move it over. I know you don't have anything to fill in here because the notes were kind of long. So you're just following along with me. So in a coordinate plane, two non-vertical lines are perpendicular if and only if, see, we're bringing back our biconditional stuff. The product of their slopes is -1. So what we're going to see is the slopes are going to be opposite reciprocals of each other. Always remember that a horizontal line with a vertical line are always perpendicular. So for example, if I were to draw that on here, here's a horizontal line, and then if I draw a vertical line, they're always going to be perpendicular. So a horizontal with a vertical are always perpendicular. So what I mean here by opposite reciprocals, so for example, I could have an equation y equals -2/3 x plus 1. The negative reciprocal, or the opposite reciprocal to that, would be positive, and then you flip it upside down. The y-intercept does not have to be the same. So what we're looking at is the number in front of x when it's in y equals mx plus b form. They have to be one positive, one negative, and then they have to be reciprocals. If it's a whole number in front, let's say it's y equals 5x minus 8, then the opposite reciprocal to that, again, I could make the whole number 5 into a fraction. Then when I flip it to its reciprocal, that 1 goes to the top, and then you make it opposite sign. And again, the y-intercept could be anything. So perpendicular lines have opposite signs and reciprocals. Parallel lines have the same slope. Let's try some sometimes, always, or never questions. So it's asking us to complete with sometimes, always, or never. So the slope of a vertical line is blank 0. And we know that a vertical line is undefined, so this would be never. Because vertical is undefined. A way that I remember that, if you think about your graph, so here's my coordinate plane. If I were to graph a vertical line, remember a vertical line goes up and down. So I use the first letters, U, and then and down, and that's sort of spelling out undefined. So that's how I can keep track that my vertical line is going up and down, so its slope is undefined. And I use the U from up, the N from and the D from down. Next, the slope of a horizontal line is blank 0, and this one is always. It's a flat line. The slope of a line that rises to the right is blank positive. This is always. The slope of a line that falls to the right is always negative. Let's practice finding the slope of a line given two order pairs. So again, I'm going to use, when I'm given two order pairs, I'm just going to use the slope formula. And remember, the slope formula is y2 minus y1 over x2 minus x1. Now, when you go, if it helps you to label your order pairs, you can do that. It doesn't matter which one you're going to label as order pair number 1 and which one is order pair number 2. I'm going to just go ahead and say this first whole column of order pairs, these are going to be my x1, y1, and then everything below this is going to be my x2, y2. And now I'm going to plug it into the formula. That's kind of messy, but let's try it. So again, y's are on top. So we're going to do 5 minus 4 over -4 minus -3. Be very careful with your signs. You need to do like a keep flip change on those negatives. So the numerator becomes 1. The denominator, this is really -4 plus 3. So the denominator is -1, which gives me -1. So my slope, that would, if I were to graph this, would be -1. Next one, do the same thing. y2 minus y1, -2 minus -3 over -1 minus 6. Keep flip change.
Miss Corey,
Yes.
I'm not sure where I went wrong, but for part A, I got 1/7.
Okay. Because did you do the same, did you put your numbers into the formula the same way I did?
Didn't take -4. I think she did. She put +4.
Did you not put -4? This is a -4 here.
Oh, yeah, never mind.
Okay.
I got it now, thank you.
All right, thank you. Thank you, Bradley. All right. So now, let's go ahead and do part B. So then this gives me -2 plus 3, which is 1. -1 minus 6 is -7. Now, you can either leave it like that, or you can pull the negative sign out in front of the fraction. Either way. Next one, I'm going to subtract -4 minus -4, and then -3 minus 8. Notice the numerator becomes 0. The denominator is -11. When I do 0 divided by a number, that gives me 0. This is going to be a horizontal line if I were to graph it. Another key thing to look at is notice the y's of your order pair are the same, so that's going through the y-axis, so this would be a horizontal line. And then the last one, this will be an example of a vertical line. Again, 9 minus, oh, I'm on highlight, let me fix that. 9 minus -2 over -6 minus -6, which gives me 11 over 0. Whenever there's a 0 in the denominator of a fraction, that is an undefined slope. Again, notice your x's this time are the same, indicating that this would go through the x-axis at -6. Everybody good at calculating slope? When you're doing this on a test or a quiz or even in the homework, be very careful with your signs. Next, we're going to complete the table based on the facts, what we know about parallel and perpendicular lines. So when a line is parallel to another line, they're going to have the same slope. When a line is perpendicular to another line, it has opposite reciprocal slopes, so opposite signs and reciprocals. So in order for R to be parallel to S, to fill in the table here, it needs to have the same slope. To be perpendicular, we're going to take that -1/2, flip it upside down, and make it positive. And now they're giving us t, so now we got to come up with the opposite reciprocal, which is -6. And then in this column, it's the same number because these two are parallel. Same thing here. The first two columns, R and S, are going to have the same number. T is going to have the opposite sign and the reciprocal of that. Next one, this is the same. This one is opposite sign, so it's positive and reciprocal. Now I know I got a variable here. If it helps you to see A as a fraction, you could put A over 1. So then when you go to flip it, it's 1 over A, and you got to make it negative. Same thing here, flip this and make it negative. Okay, example, it says if R is parallel to S, so that should tell me right away that R and S have the same slope because they're parallel. And if R is a horizontal line, what is the slope of S? So here's where you're memorizing that horizontal lines, they have a slope equal to 0. Or M equals 0, either way. Remember the letter M is slope. Let's try example 5. Now they're switching it up and test the lines are perpendicular. So if K is perpendicular to N and N has a slope of 0, what is the slope of K? Well, this is telling me that N is going to be a horizontal line. So again, in order for K to be perpendicular, it needs to be vertical. So the slope of K must be undefined. Always remember a vertical line and a horizontal line together are perpendicular. Now let's bring back and review the slope-intercept form of a line, which is y equals mx plus b. So this is the slope-intercept form of a line. The letter m, which is always the number that's going to be in front of x, is your slope. The number that's being added or subtracted to the x is going to be your y-intercept. When you're graphing, this is your beginning point. So maybe that's how you can associate the letter B with it. So here we're going to find the slope and the y-intercept. And then on the next slide, I've actually provided a coordinate plane, and we're going to graph these 3 lines on the next slide. Now, before we can do that, though, let's make sure that all 3 of these equations are in y equals mx plus b, or slope-intercept form. Because if I look at option A here, this one's in standard form, if you recall from Algebra 1. So the first thing I do is rearrange and solve for y. So I'm going to take my equation, 2x minus 3y equals 6. I want to get y all by itself. So I'm going to subtract the 2x. Negative 3y equals negative 2x plus 6. And now I divide everything by negative 3. And y equals negative divided by a negative makes this become positive 2/3 x minus 2. When you're doing the slope formula and you're subtracting that y2, y1, and x2, x1, remember if you get 2 negative answers, a negative in the numerator and a negative in the denominator, always remember a negative divided by a negative is a positive. So the slope for part A, the slope is 2/3. My y-intercept, or my b, is the negative 2. You need to take the sign that's with it. So this is b, this number is m. Part B is already set for me, so I just have to pull it out. So my slope is the negative 1/4. And my b, or my y-intercept, is positive 2. If you recall, when I went through the horizontal and the vertical lines, remember when the equation is y equals a number and there's no x here, this tells me that this is a horizontal line. And remember, the slope of a horizontal line is going to be 0. And my y-intercept is the negative 3. Now let's graph these 3 on the next slide. So let's do A We'll do A in red. So A, the equation after I rearranged it, was y equals 2/3 x minus 2. Move it down. So my beginning point is going to be on my y-intercept, which is -2. From that -2, I'm going to use my slope, which is rise over run. So I'm going to rise 2 and run 3. So I'm going to go from the -2, I'm going to go up 2, 1, 2, and then 1, 2, 3, and my next point is right here on the x-axis at +3. I rose 3 and I rose 2 and I ran 3. You can keep repeating that rise and run, or you could just stop here, connect the points, graph your line. Remember, a positive slope rises from left to right. Next, we're going to do equation B. And that one was y equals -1/4 x plus 2. My beginning point is +2 on the y-axis. Notice my slope is negative. So I'm going to go down 1 and to the right 4. You could also go up 1 and to the left 4 if you'd rather. Remember, a negative slope means that it's going to fall from left to right. You can connect your points, graph your line. The only thing that's required for a line are 2 points. You need at least 2 points. And then the last one I'll do in black. It's y equals -3. Remember, it's a horizontal line through the -3. So this would be my graph of y equals -3. So here it wants us to write an equation of the line passing through this specific ordered pair that would be parallel to this equation. So the first thing I need to do is realize that parallel lines have the same slope. So the first thing I'm going to do is pull the slope out of this equation. And the slope of this line is +2. The next thing I need to do is I'm going to be writing my second equation in this form. I'm going to be using this order pair, the -1, +1. That is going to be my x and y. Remember, in an order pair, x comes first. Same thing when you sing the ABCs, x comes first. So I'm going to replace 3 things in this equation. I'm going to be replacing -1 for the x. I'm going to be replacing the m with the 2. And I'm going to be replacing the y with the 1. I'm going to be solving for b. Now, there is also point slope for those of you who remember that equation. You can also use that form of the equation from Algebra 1. But let's go ahead and just use the slope-intercept form. So again, I'm going to put in y, which is 1. And let me go ahead and write it above. So I'm going to be putting y here. Then I'm going to be putting m, x, and I'm solving for b. So my y is 1, my m is 2, my x is -1, and I want to find out what b is. So I'm going to multiply. And over here, I'm going to be getting -2 plus b. I now need to move the 2 over. And my y-intercept, or my b, is 3. Now what I need to do is take the b, take the slope, and put them both into this equation. So y equals mx plus b, y equals 2x plus 3. This would be the line that is parallel to the given equation that they gave me at the beginning. So I'm putting in these two numbers. So I can say that equations y equals 2x minus 3 and y equals 2x plus 3, these are parallel lines because they have the same slope. Now, the positive 3 that I got was specific to this order pair. Because they asked me for a specific point that needed to be on the line, that's why I needed to solve for B. If they did not give me a specific point, I could have picked any equation as long as it had a 2x in it. Let's try now doing one that's perpendicular. So this time they want us to write an equation of the line J that'll pass through the point 2, 3, and it needs to be perpendicular to line K, and line K has this equation. I need to put it into y equals mx plus b form first because I need to get the slope of the line. So let me go ahead and rearrange. 2x plus y equals 2. I need to solve for y. If you do not rearrange your equation, you're going to have the wrong slope. Now that it's been rearranged, the slope of this line is -2. However, remember, we wanted perpendicular, so now I need to change that slope into the opposite reciprocal. So the slope for my new line is going to be positive 1/2. Now the same process for finding B, I have to do again. So y equals mx plus b. I'm putting the 1/2 here, and then I'm taking the order pair 2, 3, and that's my x and y. So 1/2 times 2 plus b. I need to multiply half of 2, which is 1. Move the 1, and my b equals 2. Now I need to take the slope and the y-intercept that I just found and put it into y equals mx plus b. So the equation of the line that is perpendicular is going to be y equals 1/2 x plus 2. So this line is perpendicular to this one because they have opposite reciprocal slopes. All right, next one is kind of long. Remember in the other lesson, 3.4, we learned that the distance from a point to a line is always the perpendicular segment. So what I need to do here is I need to find the slope of the line that's perpendicular. So I need to make it opposite reciprocal. Once I do that, I'm bringing back more algebra skills. I'm going to be doing system of equations. I'm going to find the ordered pair where they intersect, and then I have to do the distance formula. So this next example is going to have a lot of steps to it. So it's bringing back lots of Algebra 1 skills. So let's try it. So it wants me to find the distance from this ordered pair to this line. Remember in 3.4, we learned that the distance from a point to a line is always going to be the perpendicular segment. So the first thing I need to do is step number 1 is to find the slope of the line perpendicular to the given line, which was this. So that's going to be this slope here in this equation is -1. So the slope that's perpendicular is going to be positive 1. Next thing I need to do is come up with the equation of the line perpendicular, just like I did in the previous example. So I'm going to plug it into y equals mx plus b. I need to find the b. So 0 equals 1 times 1 plus b. I'm using this slope, and I'm using the ordered pair in the up at the top. 0 equals 1 plus b. Move the 1. My b equals negative 1. So my equation of the line that's perpendicular is x minus 1. Y equals x minus 1.
Miss Corey,
Yes.
so when you're saying step 1, it says slope of line perpendicular to give?
To given line. So to the given line was this. So I need to find the slope that's perpendicular to that. So over here was my slope. It's negative 1. So to make it perpendicular, I make it opposite reciprocal. So opposite reciprocal of 1 is negative 1, or opposite reciprocal of, in this case, negative 1 is positive 1. Next step, I'm going to do a system of equations to find the point of intersection. And you can either use the substitution method or the elimination method. So if you've forgotten how to solve system of equations, you might want to look up Khan Academy or just Google it and see if you can find some videos. But I'm going to go ahead and show you, and I'm going to use the substitution method. So I am working with the original equation, y equals negative x plus 3, and then the one I just created. I am going to use the substitution method because both of my equations are set equal to y. So I'm going to substitute what this y equals over here. So negative x plus 3 equals x minus 1. I now need to combine like terms. Negative 2x plus 3 equals negative 1. Subtract 3. Negative 2x equals negative 4. Divide by negative 2. X equals positive 2. I now need to take that positive 2, plug it back into one of my beginning equations to get my y. Y equals 2 minus 1. So y equals 1. So their point of intersection where these two perpendicular lines is going to be the ordered pair 2, 1. Now what I need to do is do the distance formula. So I'm going to use the distance formula using my original ordered pair and now my point of intersection. So again, remember your distance formula, you're going to subtract x2 minus x1. Again, it doesn't matter which one is which. So let me just do 1 minus 2. This will be x2, y2, x1, y1. So I'll do 1 minus 2 squared, 0 minus 1 squared, and then negative 1 squared, negative 1 squared. 1 plus 1 is 2. So the distance from that given line to that ordered pair is the square root of 2. You're going to leave your answers in simplest form. If it were a word problem, they might ask you to actually do this on your calculator, and it would be approximately 1.4. But again, we normally leave things in simplest radical form.